don't know. They said you're supposed to.
Okay, guys, we all got our math out? Yes, all of us.
I don't
Emily's
think
zoning
they're
out.
doing it. I'm just saying they told us to do it. Not here. He's hiding.
Okay, guys, we're almost done with covering this. There's just a little bit left to cover. Today you'll have your work time. Our quiz will be on Monday. So tomorrow I'll post a practice quiz. We can look at it, give more questions. Today I hope to finish this pretty quick. Just cover the last little bit. It's really easy. So, looking at 28, the last page here, the last two pages are all basically saying like, just using integral properties. So, quick little like, just using shorthand here would be like the integral. So say you have some function. If you multiply, so if you have a function and you multiply it by a constant, so C representing just some number, that's the same as that constant times the integral. That's pretty.
Yes.
For example, the little example of that would be the integral of 6x squared is the same as 6 times the integral of x squared. So hopefully that makes good sense. What else we have is the integral of like f plus g is equal to the integral of f plus the integral of g. Oh, sorry.
Yes, I would think that those are the same.
I'm using very shorthand notation just to keep the idea simple. I guess there should be like dx's there, but there should be an f of x. And then the other thing is that we covered briefly one day was, we touched on it at least. If you've got a function, I'll just use numbers to keep it kind of simple. But if you say like, here's 2, here's 5, and here's 9, just for example. And you've got a function, this is f, the integral of your function from 2 to 5 plus the integral of your function from 5 to 9 is the same as the integral of your function from. Does that make sense to everyone?
Mm-hmm.
That's pretty, like, it's a very simple idea, but you can sometimes get lost in the weeds if you're doing a question and you're like, what kind of caption are you gonna put on that? Felt cute, might delete later.
Yeah.
Okay, so.
It's MDL.
What?
MDL.
MVL?
MDL. DL.
What's that?
Oh my god. Never mind. Might delete later.
Oh. Okay, FC, MVL. Okay. I like to do MVL.
I didn't.
Maxime Vachier-Lagrave.
Oh, clearly. I'm
One of
sorry.
the top contenders in the chess world right now. Great player. Will he qualify? Yeah, will he? Well, he has to qualify for that in the candidates tournament, but we'll see if he can do it. If he can pull himself up by his bootstraps. Okay, so 28A, for example. Watch how simple these are. You guys are gonna like these. They're very, very quick.
Beautiful, beautiful marker.
Oh yeah, new marker. New marker, new me. This says, given that the integral of f plus g from 0 to 4 is 10, and we know the integral of f from 0 to 4 is 3, what's the integral of g from 0 to 4? Who knows the answer to that intuitively? 7. Okay. If you want to write it out, you'd go, well, it's basically this property. So they're telling us, now the thing is it's the same down, 0 to 4. So if we know that the integral of the functions added together is 10, and we know that the integral of f is 3, then that means our g integral must have been contributing 7 to that. So, make sense?
Mm-hmm.
Pretty simple, right? B is pretty similar to that. What if, so the integral of f minus g is 8, so integral, that was A.
It's B.
The integral from 1 to 5 of f minus g would be the integral of f minus the integral. Nothing crazy there, right? So they're telling us that this one was 6. So this guy contributed 6. This is the thing we're solving for. And this whole thing over here was 8. Yeah, so what's the answer? Negative 2. Okay. And then look at C. C again is hopefully pretty straightforward. It's going, that's more like this idea. So C is touching on this concept of, I don't have a sum of functions or a difference of functions. I have basically a sum of one interval plus the other interval. So this one says, if the integral from 1 to 3, well, first I might write it like this. The integral from 1 to 3 plus the integral from 3 to 7 would have to give me the integral from 1 to 7. Then they tell us that from 1 to 3 we had 8 area, and from 3 to 7 we had 6 area, and so 14 must be the answer.
Well, can you go walk by the heater thing?
I don't know what I can do. I mean,
Well, usually you just walking over there stops it.
it's a good example of a damping an oscillating system. Damping. There you go. Just needed some more damping.
Oh boy.
Right. Okay.
I
No
sneezed.
sneezing. No sneezing.
In my tooth. Walking.
So hopefully that'll and then don't forget the other thing that we've talked about, which is like this is kind of getting into like the next page. So hopefully that's enough of an intro that you can complete 28 and most of 29. Just bear in mind, guys, that like, just for example, if you're like, oh, let's just do it together. Let's look at like 29b, for example. 29b tells us some info. It says, hey, I've got this function where the integral from 0 to 5 is 5, great. And then the integral from 5 to 6 is 2. So first of all, what's the integral of f from 0 to 6? 7. But it's not asking that. It's asking what's the integral from 0 to 6 of 3f plus an extra x. So there's two ideas here. Actually, maybe there's three. There's three really. Idea one is that I can split this up into a sum of integrals. Okay, so so 0 to 6. Is it okay if I do 2 at once? 3. I'm going to split this up into 2 integrals, but then also pull the 3 out. Holla at me if that's confusing. Does that make sense or no? So this integral, this one, I mean, you could do it in your head, but this one's gonna be, I'd probably recommend not trying to do it in your head. Maybe if you do a few and you're like, oh, it really totally clicks for me. But anyway, so we know that because going from 0 to 5 gets me 5, and going from 5 to 6 gets me 2, going from 0 to 6 gets me, like you guys said, 7. So what's this expression going to be? 3 times 7, 21. And then don't freak out on this. Is that a challenging question? No, that's actually an easy question, right? Yeah, that's, oh, what's the integral of x? It's, sorry, I'm running out of room here. I'll write it hide up. That by itself is just like a little isolated, kind of like an easy calculus question by itself. It's sort of just tacked on. So anyway, the answer to that would be 1/2 x squared from 0 to 6, which is going to evaluate to, we'll plug in 6, 36 divided by 2 is 18, minus plug in 0, you get 0. So this guy is actually just contributing 18 to the sum. So the overall answer is 39.
Wait, where's the 18 come
Yeah,
from?
can you go over that?
We should plug it in the 6.
So, so this is coming from the given information of the question. This is the given. You can't really proceed on the question unless they tell you some information about what f is like. This is just a standalone thing. No matter what you're doing, the integral of the x function from 0 to 6 is always going to be 18. That's just a given. That's just a fact. What? Why? So I did it over here. So the integral of x. This is coming back to the first thing we did this unit, which is if you integrate x, you go 1/2 x squared, and you got to plug in the 6, and then you plug in the 0 and subtract them. Another way to look at it, of course, is if in most functions you can't do this very easily, but if you graph y equals x and then take the area from 0 to 6, that area is 18. So the way to think about this is like this function had 7 units of area between 0 and 6. We tripled the height of the function, which tripled that area, 21. And then when you added x onto your function, that actually contributed that much area. So that's actually a fact about how these functions work. When you add, so that the y equals x function has 18 units of area between 0 and 6. So if you add x onto any function, that's how much area you're going to be adding onto that function. Make sense?
Yeah.
Interesting.
Okay. And then last thing.
Mr. Paul? Just a clarifying question on 28E. Does the progression of like which you order the integrals would you first go 0 to 4 plus then the 1 to 4 to 6?
Mhm.
Okay.
Yeah, the way this information is presented might seem a little bit out of order sometimes, but you just got to start. You can always start with like the real basics, like you said. I'm just going to start by writing the integral from 0 to 4, but in super shorthand, it's the area from 0 to 4 plus the area from 4 to 6 would have to give me the area from 0 to 6. And then once you have that established, you plug in the information that you know about. So in E, you're given this number, and you're given this number. Okay.
Can you go over C,
28C?
29?
Yeah, sure. Yep. Mr. Teletubby has failed us. Sad. Not lit. How dare you?
I don't get it, There's no sun, baby?
Yeah, there's no sun.
No babies.
He said he was going to come out, or he appeared to be that way, but he didn't. Okay, here you go. By request. So 29C. They're giving us, the integral from -2 to 7 of f. They give us that information. But the area, so just kind of, that could be f, whatever. Probably a bad picture, but the area from -2 to 7 would have to be equivalent to the area between 1 and 7. So the area from 1 to 7 plus the area from -2 to 1 would have to add up to the total area from -2 to 7. So I could start off with something like this. This is a true, it's kind of like the Winslow and I were just talking about, where it's like, start with that, just something really basic, like that's got to be true. That's how you do it. A lot of math questions, if you get stuck, you just go, you write down something you know must be true logically. And then you go, okay, well then what did they give us? They gave us this number. From 1 to 7, the area was 3. They gave us the total area was 13. So we have at least one nugget of information, which is that the area between -2 and 1 has to be 10. So in my picture wasn't very much to scale, but that area had to be 10. Just a sec. All right, what's up, Aiden?
Where is the 4 go?
I didn't get there yet, but that's good you're thinking of that. Because I saw in the question that it seems pretty clear that I'm going to have to know what is the integral of f from -2 to 1, right? That seems like fairly evident in the question, right? So now I'm prepared. I'm going to maybe put a little reminder. There you go. So now the question's asking us to evaluate what's the area from -2 to 1 of 4 minus f of x. So now two things. I got to split it up. So you can't bring the 4 to the outside. Okay, so holla at me if this is confusing. Right? Make sense? So you split it up. Here's a good little test. Who can do that in their head? Maybe you can. If you can't, it means you're maybe missing a visual element of things. Who's got the answer? What's that in their head? 12. Why? Well, if you graph y equals 4, and then take the area from -1 to 2, what shape is that? Rectangle. It's a 3 by 4. What?
-1 to 2.
It's 3, right? 3 times 4.
No.
It's
It's -2.
Oh, okay, thanks. I wrote these backwards.
Yes, okay.
Thank you. So the picture's extra crappy now, but you get the idea though.
Yes.
Well, my point I'm trying to make is if you can understand that the integral is talking about an area, and then understand that this is a flat horizontal function, well, your area is going to be a rectangle, which is easy to calculate. If that didn't occur to you, that's fine. You can calculate it. What's the integral of 4? 4x. I mean, most of the time on these, you probably can't just calculate it by visualizing a rectangle. What if it's a parabola? What if you're adding a parabola onto your function? You're going to have to calculate that. Anyway, plug in 1, plug in -2, and subtract them, you're going to get 12. Is this making sense?
Yes.
And what's this guy? This guy is 10. So this is a known value of 12. So 12 minus 10, the answer to this question the whole time was 2. Do we feel, how are our feelies? Okay, I got to cover one more thing and we're done. And you guys can have the rest of the class to work on, to knock out a bunch of your questions. The last page, it says these ones are a bit trickier. Okay.
Which ones?
Let's do 30.
I think I got it.
What?
I really emphasize the part that says these ones are a bit 12.
Okay. So, let me give you an example of, this is one that if you just say you were taking a university class and they tend not to give you so many examples in those classes. Let's say you're in kind of question like this, and they're just hoping you like figure it out. And you say, this is a great example of one where a computer can be extremely helpful. So I'm going to show you how I would investigate this question with a computer. What? For the first one? 3 is a good guess. Anyone else got a guess for 30A? Could be 6.
24.
24 is a reasonable answer.
I don't know.
These are getting bigger and bigger.
48.
48 is a good answer. How about 12?
Why?
Sometimes in
yeah.
math you go, oh, like we did something, but it didn't change the whatever, right? That happens a lot. Let's see. So I'm going to say, I don't know. I'm going to show you a kind of like I'll prove that this is a general rule, but like, watch this. What if I say f of x equals, let's pick an arbitrary function. X squared, let's pick something kind of weird maybe. X squared. Okay, that's sure. Whatever it is. Anyway, I just made up a random, you pick a random function and I say, well, okay, computer, what is the area from 0 to 10
Okay.
of my, okay, it's this value, all right? But then what if I ask the computer just what's the integral of 0 to 5 of f of 2x? And what do we notice? It's exactly half as big. So you're like, oh, is that a coincidence? Let's say I changed the function. What if I did something weirder like square root of x plus, I don't know, x over e to the x. That's a weird looking function. Oh man, that's a really weird function I just made up. But look, the relationship is still there, pretty clear. So let's look at, so we're pretty confident then that this thing where you're not only going f of 2x, but you're also taking the integral over half the width. It gives you half the area. So why is that? I'm going to draw a little picture here. So this is f. Suppose just for a moment that the function looked really nice and friendly like this. Okay. Well, what happens if you graph f of 2x? Does anyone remember what happens to a function with graph? It's a horizontal compression. So you're going to have all the same behavior. So this region would basically be, I tried my best, I kind of messed it up, but you get the idea hopefully. It's going to compress all those same y values into the same, all those same y values will get hit, but over half the distance. So then you might go, well, if vertically speaking, it's all the same, like we tallied up all these y values, if that's all the same, but we have half as much horizontal space, then it stands to reason that it should be half as much area. I'll give you one more quick explanation. This one tends to confuse people, but it's worth seeing. Integral of f of 2x from 0 to 5. Do you see how you can see this as being like f of u? Yeah. Kind of like a chain rule thing. So the idea would be this is f of u. So you'd want to have a u prime there, which means I'd have to put a 1/2 out here. And then reverse chain rule says I have 1/2 of now this would basically be the integral of f of 2x. And so what you'd have is, I mean, I'd have to write something like f to represent the antiderivative, but f of 2x from 0 to 5. But here's the thing, now when I plug in 5, I get f of 10 minus f of 0. And then if you look at the original thing, well, isn't the original thing given fundamental theorem of calculus? Does that make sense?
Yeah.
I'm thinking of big F as being the antiderivative of little f, so some function. Okay, so if I evaluated that, I would antiderivative him, plug in the 10 and the 0, but that's exactly what I have here. So how big is that number? 12. 12 times 1/2 is 6. So that's more of an analytic proof of why that's true.
Yeah.
The area thing is hopefully more intuitive for you. This is one of the reasons why I try and, our pre-calculus, I try to emphasize the whole graph, shifty, stretchy thing. In any case, how about B? What's happening to the interval?
Getting, it's one compressed by 3.
It's compressed. The whole interval is compressed by a factor of 3, right? So the answer is going to be what? 8. And then for C,
Being it's gonna be 32, right?
very good. Yeah, it's going to stretch that thing out by a factor of 4, right? So when you replace the x with the 1/4 x, you're actually expanding it horizontally. And the interval has to expand with the function. So, for example, if you asked for the area of f of 2x from 0 to 10, you're going to have a hard time making any kind of claim that you know what that is. It has to be, anyway, it has to do with this reverse chain rule. So, then the very, very, very last thing, this is kind of an afterthought, but 31. Let's see who knows. Who knows this one? Let's see. Given that the integral of some function between -3 and 3 is 0, what kind of functions would be guaranteed to have that property? Close, odd functions. So this is knowing even and odd functions is very helpful when you're doing calculus because, first of all, a lot of these, you don't really know how to integrate them. Something B is pretty easily integrable, but A, so far in this class, we do not know how to integrate A. D is a really tough one to integrate. I don't think I know if there's any technique that's lets you do that by hand, but anyway, my point is, if you draw any odd function, so it could be something really wacky like, I kind of got it correct. If you draw an odd function that has origin symmetry, and then you pick a symmetrical interval, for example, from -3 to 3, what's always going to be the case? You're going to have just as much negative area as you have positive area. What does that mean for the integral? It would have to be 0. Does that make sense?
Yeah.
Then how about 32? 32 is just saying what kind of function would have, logically you probably know what's coming, right? 31 is about identifying odd functions. But do you see why do you see why 32 describes an even function?
Yeah.
So it says so for an even function, if the integral from -5 to 0 is the same number as the integral from 0 to 5, meaning it has perfect symmetry. Although it does say could be. You could have some wonky function that's not even or odd and just coincidentally has this property, but anyway, so 32, we're looking for an even. No confusion? No tears? Johnson & Johnson's corporate sponsor. Okay, you got about like 17 minutes. You can just work on some problems. Let me know if you have any questions.